There's no doubt that the El Reno tornado of May 31st, 2013 has captured the imagination of the weather community. A lot of this is due to the death of beloved storm chaser and scientist Tim Samaras, his son Paul Samaras, and his longtime chase partner Carl Young. Other factors play into El Reno's reputation: its record-setting width, the bevy of chase videos due to its proximity to the storm-chasing mecca of Oklahoma City, and the tornado's somewhat anomalous behavior. But what if I told you that the 2013 El Reno tornado is, in fact, overblown? What if I told you it wasn't even the strongest tornado to hit the El Reno area in a 2-year span? What if I told you to stop talking about it, to not focus on it, that it wasn't special, that it deserved its EF3 rating, that it... Okay, sorry about that. I'm gonna take a deep breath. Drink some coffee. Okay, the 2013 El Reno tornado actually was fascinating. I've consumed almost every video and documentary about it that the internet offers, from Skip Talbot's classic Safety Lessons from El Reno to Dan Robinson's incredible escape footage, and so much more. Link to both videos in the description. And for those of you who read, and I know there are a sad few of you out there, the Tim Samaras biography, The Man Who Caught the Storm, contains, of course, a whole long chapter dedicated to this terrible day. El Reno was a monster, and one that caught many very experienced storm chasers by surprise. So I guess what bothers me about it is the over-fixation by the casual weather community. Many people I encounter in comment sections and storm-chasing video games seem only to know about El Reno, and perhaps Joplin and like 3 or 4 other storms. I made a video a while back, 5 tornadoes you probably haven't heard about but should, that tried to draw attention to 5 other tornado events that deserve just as much attention. This video is of a similar vein. Let's loosen El Reno's grip on your imagination and realize there are plenty of other tornadoes we can dive deeply into with the same ravenous fixation. So let's start with my first claim. El Reno 2013 was not even the strongest tornado to hit the El Reno area in a 2-year span. This honor should go to the 2011 El Reno EF5 of May 24th, 2011. Okay, it's true. Some of you will correctly argue that the 2013 El Reno tornado did have stronger winds as measured by the Dow. However, those were fleeting in the many subvortices that had developed. The 2011 El Reno EF5, on the other hand, had a much stronger parent tornado, and Raxpol radar recorded winds of at least 295 miles per hour. It was longer track, deadlier, and generated some truly mind-warping damage indicators, including tearing engine blocks out of cars and tossing them thousands of feet, and rolling a 2 million-pound oil drilling rig at least 3 times. This was a tornado of truly epic fury. Point 2. The 2013 El Reno's EF3 rating is accurate. Ugh, ratings debates. Look, I'm an advocate for science, and the current scientific value of the EF scale is dubious at best. The reason I say this is simple. We're not getting accurate ratings of tornado strength, and only accurate ratings would be valuable in learning about the frequency of these highest-end tornadoes. I mean, how many times has a tornado been downgraded from EF5 to EF4 due to some rusty bolt in the foundation of a house? There are so many examples of extreme tornadoes getting a lower rating due to the construction quality of the buildings it impacted, from Mayfield to Rolling Fork to Valonia and beyond. But the EF scale, as it currently stands, is a damage scale only. Radar measurements, anecdotal evidence, and even direct Dow readings simply can't be used. And therefore, since the 2013 El Reno tornado, thankfully really, mostly spun its life out in a field, it just didn't do the damage to warrant an EF5 rating. Of course, everybody knows this tornado was capable of EF5 damage, but it just didn't. Therefore, the EF3 rating is right. Hopefully the next iteration of the Fujita scale does a better job of actually capturing the strength of tornadoes. Point 3. El Reno is not that special. There are two things people point out about the 2013 El Reno tornado to claim that it was special. One is that it was so wide, and two, that it had deviant motion. So let me shred both of these points one by one. El Reno is widely cited as being the widest tornado on record, and that's technically true. Its tornadic wind field was determined to be 2.6 miles wide. However, most of that wind field was really just the bear's cage, which happened to strengthen enough to reach tornadic wind speeds. This wind field was mostly uncondensed, and therefore invisible. The widest condensation funnel ever, however, belongs to the mighty 2004 Hallam tornado. This tornado was 2.5 miles wide, so barely less than El Reno. But the vast majority of it was actually condensation funnel, so visually this would have been a much wider and massive looking tornado. Also, there are some studies that suggest the 1999 Mulhall tornado was as much as 4 miles wide, which, if true, would have made it wider than El Reno by a lot. This tornado was pretty fascinating and deserves a deep dive on its own, maybe in a later video. How about that deviant motion El Reno demonstrated? Here's a look at the Jabba the Hutt slug trail of El Reno. It was a bit unexpected that it started moving south initially. Most tornadoes move southwest to northeast. This caught some chasers by surprise, as is clear from the videos of the tornado's original touchdown, where chasers who were originally stationed just to the southeast of the storm had to flee as it barreled towards them. The southeast portion of the bear's cage is a common viewing spot for most tornadoes because you get the best chance at a clear view without being in the path or in the forward link downdraft. The tornado then surprised everyone yet again by turning almost due east, which made it seem to chase the chasers, who were fleeing to escape the apparently south-moving storm. Of course, it also expanded at this point rapidly, which would have made it seem like it was coming at you almost no matter where you were. Then, finally, as the tornado occluded, it turned north toward the interstate where it caught even more storm chasers unaware. This northward movement is common for occluding tornadoes, though. This path is a bit odd, however, but there have been some tornadoes that have demonstrated much more bizarre motion. Take the 1980 Grand Island tornado family movements. Look at these two tornado paths and try to tell me that the El Reno path is weirder than that. Insert mic drop moment here. Shit. I didn't mean to actually drop my mic.
Waiting for my train to come, waiting for my train to roll on by.
Alright. I'm not contrarian by nature. All this was, to some extent, tongue-in-cheek. It's not a battle against El Reno I'm waging. I'm just trying to expand your knowledge about tornadoes and pique your interest into storms that you might not have heard of. Anyway, thanks for spending a little bit of your precious time with me. It means a lot. See you next time.
Waiting for my girl to show. She's holding out for what I just don't